Welcome Todd Yakum. Welcome Tom, Stuart, Ryan, Manuel, Jerry, Gennady, FH2, Dennis, Breno. Welcome Alan Tal. Welcome again. So many nice people, so many familiar names. And we have people from all over the world. Today I'm in Singapore for an occasion. And we have Dale. Dale, where are you joining from?
I'm joining from home, which is I'm in Scotland now. So, welcome from Scotland. I'm the only ClickHouse person in Scotland. I'm sure there'll be more soon.
It should be a nice weather, like rain, wind, right?
Yeah, the sort of weather that you and me love, Alexi.
Yeah.
How is Singapore? I imagine it's quite. Is it usually as usual, very humid and hot?
Hot and humid. Yeah, exactly.
Yeah, I
But
struggle.
anyway, uh, if you go anywhere, there is a huge amount of air conditioning, so it doesn't feel so cold. Sometimes it feels chilly.
Any other cities you're in, if people would want to be interested, or is it just Singapore? If people want to reach out to you and they want to meet you, is there anywhere else you're going on your travels?
Tomorrow I will be in Melbourne, then Sydney, then Bangalore.
Okay. Well, to all of our attendees, Alexi's on the road, so if you maybe you'll catch him in one of those cities in the next 2 weeks.
Maybe you'll travel with me to catch all the meetups.
Maybe I know I'm in Dublin the week after next, and then we have Atlanta KubeCon, obviously, and about a lot of big events coming this time of year. Shall we start? I think we have a fairly stable number. Alexi, do you want to kick us off? We're at
Yeah, let's
20
start.
and quite a decent number on YouTube as well. Let's go. So 25.9. Over to you, Alexi.
This is ClickHouse release 25.9, ClickHouse Autumn release. And we have a lot of features, and we have two guests today with interesting topics. So let's start with some numbers. We have 25 new features, 22 performance optimizations, and 83 bug fixes. And let's start with small and nice features, as usual. And just a few usability improvements. The first improvement is about settings. How to set a flag, feature flag in ClickHouse, or how to enable or disable some flag, like use query cache. In previous version, you write set use query cache equals to true. In the new version, you can just write set use query cache and that's it. Set enable parallel replicas and that's it. You don't have to write equals to true. So this is a small change. It will make a small difference. So let's move on. The next one is a new function, and it is quite a small function. Name it isValid ASCII. It just validates if the string is in ASCII. So this string is definitely is, and the function returned 1. This string is definitely no, it is Unicode, and the function returned 0. And actually you don't need this function, because you can always do it like this with a regular expression, or like this with another regular expression. And if you want to show off, you can do it like this. Extract every character in an array and compare its code to 128, and it will do the same. But in the new version, you don't need all of this, stuff, you just write select is valid as key. Looks pretty nice. And the next small feature is again a new function named array except. It just removes all the elements that are present in the second array from the first array. And again, you don't really need this function. You can write it like this with a higher order function, array filter. You can write array filter x not in another array and apply it to the first array. But in the new version, you simply write array except the first array and the array of what to subtract. It works in the obvious way, so nothing to look here. Let's move on. And the next one is about S3 table engine and S3 table function. And the change here is, again, pretty simple. A new parameter, storage class name, that allows you to define the name of the storage class like intelligent tiering or standard infrequent access or Glacier Deep Archive. Again, pretty obvious. So you can create a table with engine S3, insert into that table. You can also insert into a table function. And by the way, if you use S3 disk, the storage class was already available. So this is a small change. The next small change is a new system table, system.database replicas. It allows you to introspect databases with replicated engine. You know, we already have a table system replicas for introspection of replicated tables. So now we have a similar table for introspection of databases. And it provides you the information about if the database is read-only, how long does it behind in the replication queue, what is the zookeeper path, the total number of replicas, the last exception, if session was expired. It's a pretty simple table, and it will help you with your operations with ClickHouse clusters. And another small feature is an advancement of our experimental support for arrow flight. You know what arrow flight is? If you need this feature, you definitely know. But if not, let me explain. Arrow flight is a protocol for communication between servers and clients that uses Apache Arrow format and a pretty simple RPC that is aimed to replace something like ODBC, JDBC, but to be native for column-oriented databases, to transfer column-oriented data efficiently. And you can use Arrowflight with libraries like PyArrow. So since the previous version, we had just the first prototype implementation. It was working, but now we also have implemented TLS and authentication. It is simple to use, so for authentication, you just define it as parameters in the table function or table engine. So it is on the path to being production ready, hopefully in one of the next releases. Another feature which is way more interesting specifically for me and for our engineers who often optimize something for production, who often investigate the memory usage. It is a new memory profiler. And actually it is like the third memory profiler that we have in ClickHouse. In ClickHouse, we already have a sampling memory profiler that will record a random subset of allocations and deallocations. and a watermark memory profiler that will record a place in the code of the allocation whenever the total memory usage for a query exceeded a certain threshold like 1 gigabyte, 2 gigabytes, 3 gigabytes, so it is named watermark memory profiler. But the new memory profiler works by reusing the feature of low-level memory allocator from C. We use JE_malloc, and it provides a way for consistent sampling of allocations and deallocations. So it will record not every allocation, but certain subset, maybe once 100 or 1000, I don't recall. And for every allocation, it will also guarantee to record a deallocation. So it's like a sampling memory profiler, but which is consistent. And now it is built by default. So ClickHouse in production will already contain this memory profiler. You only have to enable it. You can enable it per query or globally on the server level. And then the data will be collected in the system table named system.traceLog. So you can analyze like top places with allocations, largest allocations, queries with the most allocations, etc. And let me show how to use it. Let me show how to use it. I will switch to my terminal and try to show a demo. I have my server here. And I will connect with ClickHouse client. The server is already updated to the master, so it's not just 25.9, it is actually pre-release 25.10, which is a few commits ahead of the release branch. And I will copy-paste queries that enable memory profiler. So first of all, I will enable these settings. JE_malloc enable profiler and JE_malloc collect profile samples in trace log. It will enable the collection in the system table. And you see, I already use our new feature. I did not specify the values of these settings. Now let me improvise and do a query that's supposed to use a certain amount of memory, so it will be recorded. This query will do aggregation by 1 million keys, and it processed 5 billion rows. It is pretty fast. And it consumed almost 3 gigabytes of memory. And as I enabled the memory profiler, the data should be recorded in the system trace log. So what do I have in the system trace log? I have an array of function names, named symbols. I have the size of each allocation, which could be positive for allocations and negative for deallocations. And I can analyze the average allocated size. Let's see what will happen. And here are top 20 places in the code where something was allocated in this particular session, because I enabled it for my particular session. So this one allocates something in function modulo of division. Yes, I did use the function modulo of division. And these are the names of functions from C++. And the average size of allocation was 0.5 megabyte. And I can actually calculate that it is like something 64,000 or 65,000 multiplied by 8, probably. Okay, so it does work. And now let's take a look at performance improvements. We have performance improvements in each ClickHouse version. And in this version, I have particularly exciting, particularly interesting performance improvements for you. Let me see. The first one is a different way for processing secondary indexes. Secondary indexes like min-max or set indexes with a set of values, or Bloom filters with data sketches, or even vector indexes or text indexes. So what is the difference? In previous versions, when you have an index and you query a table, the index will be analyzed before the data, actual columns, will even start to be read from the table. And if you have a particularly large table with particularly heavy indexes, like Bloom filters, you might see a significant delay before the query will even start showing the progress bar, before it will even start processing the data. And in the new version, the idea is that actually the index exists parallel to the data. It exists and mapped to similar granules of the data. And while we reading the index, we can also read the data at the same time and do the filtering incrementally. So instead of reading the whole index and analyzing it, we like have two cursors in the index and in the data. And these two cursors will stream across the data, reading index and the data at the same time. Maybe it sounds complicated, but actually the difference is if a query can finish earlier, like when it has a small limit, and you do something like analyzing your logs, and you don't need to output a million of records. You can stop after finding like 20 of records. Just enable this setting and it will give this behavior. Let me demonstrate it on one example. And for this example, I will use another server named CI logs. It contains large tables with trillions of records, with logs from ClickHouse server, from every test run, from every check that we apply in each pull request and each commit. So first of all, let's take a look if I have any large indexes on this server. To figure it out, there is a system table named system.dataSkippingIndexes. And I will select the largest ones by compressed size. And yeah, we do have a lot of interesting tables like text log with index of 6 terabytes compressed. And this is just index. Could you imagine how big is the data, actual data of this table? Or asynchronous metric log with it is not so big, just 1.7 gigabytes. So let's take a look at any of these tables and try to understand the difference. First of all, the size of this table, how big it is. Asynchronous metric log contains 200 34 billions of records. Okay, not so big, not so small. By ClickHouse, by the ClickHouse standard. Let's take a look at the structure. And in the structure, we have our usual stuff like event time, metric value, but also instance ID, instance type, check name, commit, pull request number, repository, and a few indexes. An index by commits, by pull requests, repositories, and by the time. And these indexes are interesting because they will contain up to 100 values for each granular. And now let's do some selects. The first one will be without the new setting, as usual, and we will try to find commits that contain this 4 digits A in hex. Okay, so I started it and the query should start, but it does something. Okay, it spent like 10 seconds for just something like analyzing the index. And now it is ready to output these commit hashes as we wanted. I would not say this query is slow, it is not slow, just the volume of data is significant. But I don't like just sitting and waiting while it will finish. I can say that the performance of this query is reasonable. But reasonable, it will be just a word that I substitute when I don't really like what is happening. If I really like it, what is happening, I would use another word like unreasonably fast. And here it is reasonably fast. 32 seconds. Just in case I will run it twice, because what if caches were slow? But maybe I should not run it twice. It is slightly faster. Yeah, 8 seconds. And now let's compare what will happen if I enable this streaming reading of indexes. And now I have a question for Dale. Dale, could you please try to guess how fast this query will run with the new setting?
I'm going to say 22 seconds.
22 seconds. So do you think that it will be slower?
I think
Because
without the preloading the index. But the index is already preloaded at this point now because you've run the query once. Can you can you compare it against the unloaded version? I was comparing it to the 32-second version.
Okay, but this is an important point because indexes are typically not cached in memory. There are marks which allow to read indexes and the actual data of indexes. And what is cached in memory, it can be just a page cache from the operating system, or for this particular cluster, it is distributed cache in ClickHouse Cloud. But indexes still have to be read and deserialized and analyzed. And this deserialization takes time. It takes time even if the index is loaded. Okay, I will not.
I'm going to say 6 seconds then.
Okay. First, we noted that there were no pause before it started processing the data, as expected. But will it be fast? Will it be fast? 7 seconds. You are almost right, but not quite. You're just slightly more optimistic that you. Actually, please be that optimistic. Yeah, it is 1 second, 1.5, almost 1.5 seconds faster, which is something, but not as fast as Dale wanted it to be. Okay. Uh, the next performance optimization is way, way more interesting. And this is what many of you dreamed of all the time and asked us all the time. And now your dream came true. Now we have automatic join reordering in ClickHouse. It supports arbitrary graph of joined tables. It can be tens of tables, hundreds of tables, joined in a different way with left join, right join, inner, full outer join, any join, semi join. And it automatically selects the best order using a certain data. It can use just the amount of data expected to be read from each table after the index analysis. So it will put largest amounts, tables with largest amounts first and smaller amounts later. Or it can use column level statistics. And for statistics, it is especially useful because it can then analyze what the data amount will be depending on the conditions. And we have two settings. The first setting will enable the maximum number of tables to apply this reordering. And the second will enable the usage of statistics, which are also quite a new feature. Let me show it in action. Let me show join reordering. First of all, a primitive example with a synthetic test. I will use this server, and on this server, let me actually use ClickHouse local. I don't want to like pollute this server. So I will instead run a ClickHouse local. And I will create two tables named big and small. The first one will contain 100 million records, and the second one just 1 million records. Now let's try to join them. First, I will join them without enabling this setting. By the way, it is enabled by default in 25.9. So here I explicitly disabled it. And the query took 1.8 seconds. 2.81 gigabytes per second, which is pretty good. And I would think this is a good performance. But now let's enable this setting. I set it to 10, so it can reorder up to 10 tables, although I only have 2. And now this query is at least 3 times faster. At least. But this is just a synthetic query, nothing special. I just made it up, joining 1 million records to 100 million records. More interesting is I can also demonstrate it on a classic benchmark, slightly outdated but still classic, TPC-H. ClickHouse can run TPC-H successfully out of the box with pretty good performance, and now it can do it even better. Let me again use this server and copy paste some queries. Here is ClickHouse client, and I created two databases named TPCH without statistics and TPCH with statistics. And to demonstrate this, I will enable all the settings, including statistics usage, and run a certain query, probably query 5 or query 7, I don't recall, but this is a query from TPCH. And first, it's like the behavior that you get in 25.8. And this query runs. It runs and it continues to run. It continues to run to my disappointment. It does something. And you might think that it does something useful. And if I'm bored, I can just press spacebar and look at the metrics, and I can see it does a lot of join probe. It returns join result, sends bytes over network, but it does not read data right now. So it does something. Actually, I don't like this result. Let me terminate this query. It did not finish in 1 minute. And now I will use another database with statistics and run the same query. And what do you think, how fast it will be? Dale, your hypothesis, your guess.
I'm going to give it 10 seconds.
Oh, okay. 10 seconds. Sounds modest. Maybe 1 second. No? Okay. It is less than 1 second, just 700 milliseconds. And the difference is huge. I don't even know how the previous query ran. Probably it runs in 5 minutes, I don't know. Maybe it does not run at all. Okay, so this is a huge optimization. And if we just look at the full results of TPCH, all 22 queries, at the left, you can see manually optimized queries. So if you manually reorder joins, it will obviously be the fastest one, but you don't want to do it. And if you use statistics, certain queries will automatically be optimized like from 10 seconds to 4 seconds, or more importantly, from no result, no successful result, to a successful run close to the optimal timings. Okay, now something interesting. What are the main features in the new release, if not join reordering? And the first one is particularly interesting because it is a new implementation of full text search index in ClickHouse. And if you followed our release calls, change logs for many years, you know that actually the full text search is in development since 2022, for 3 years already. And the first prototype has been around from 2023, implemented by external contributors Harry Lee and Larry Lua. But it was not production ready. Certain characteristics were missing. Certain must-have stuff was missing, and in some cases it did not work well. We had to rewrite it, and now we rewritten it, and we have an entirely new implementation that we plan to make production ready. Now it is still experimental. How does it work? How does it look like? You create a table, you specify an index on top of your string field with type text, just text. Optionally, you define a custom tokenizer. It can be a default tokenizer that splits text into words. There is also a special tokenizer for logs, name it split. It gives better segmentation of data that is typically found in machine-generated logs. The granularity can be quite large, as 100 to 1000, which is okay for this type of index. And then if you use one of the following functions like has token, search all or search any, this function will benefit from the index. Has token accepts just a single token. Search all and search any accept an array of tokens, which you could also generate dynamically from your string, like your query. So let's take a look. Let's take a look how fast will it be. And I have a server in ClickHouse Cloud updated to 25.9 where I have a table with inverted index. First, let's take a look at this table, how big it is. It contains 9.10 billion records. What type of records? We will see. This type of records. Basically ClickHouse logs, plus enriched with some data like instance type. It's again logs from our continuous integration system. And we want to search on top of this text messages. So let's do a query that should already benefit from the index. Keep in mind, this is almost 10 billion records. Messages are strings that are quite large. And let's do this query. And it finished in just 58 milliseconds. Instantly. It instantly found the relevant logs, which is just perfect. I did not even expect such a good performance. Now let's compare what will happen if the index cannot be used. If the index cannot be used. Yeah, I can do this query with count, or I can, as usual, select messages. So let's try to do this query. And it processes data with almost 50 gigabytes per second. But I don't need this 50 gigabytes per second, I just need it to be fast. And it is not as fast because it cannot use the text index. And the text index makes a huge difference for logs data, for observability data. And it is actually one of the most demanded, one of the most wanted features from our customers. And now we have the first experimental version that is aimed to be production ready in one of the next releases. What else? And we also have another index, another new index that was in development since 2021. So it is for 4 years already. And it has been made production ready just recently in the release 25.8. This is index for vector search. It is named vector similarity, and you specify the algorithm. Currently, there is only one algorithm, HNSW, the distance function, vector dimension, quantization level, the number of edges in every node of HNSW graph, and the parameter for construction of the index. It is recommended to create a table and create index then, rather than create an index and insert a lot of data. You can do either way, but the way with asynchronous index creation, late index creation is just more efficient. And if you do a query sorting by this distance with a limit, it will use this vector similarity search. It can do, and it will do approximate vector similarity search with the recall depending on the parameters. So what is the history? We used to have experimental version with different algorithms since 22.9. It was not practical. It proved to be not practical, so we replaced all the algorithms to a single algorithm and single library, named usearch, and the algorithm HNSW in 23.8. But it still was not practical because it did a lot of unnecessary work. It was not as fast as specialized vector databases. This year, in January, we made these indexes much faster. In 25.5, it became beta with pre-filtering, post-filtering capabilities. In 25.8, we made it GA. We removed unnecessary reading, introduced a lot of quantization options, and even submitted our entry to ANN benchmarks, so it will be competitive with specialized vector databases. The algorithm is HNSW. It supports everything you need. You can filter by vector index and any other conditions in the query, and you can choose between pre-filtering, post-filtering, and with post-filtering, you can even choose the multiplier. Okay, so it sounds pretty nice, but we also have a lot of improvements for data lakes, like the support for alter update or support for unusual data formats like ORC and Auro as data files. Unity catalog is implemented on Azure. Insert select became distributed. But we have something even more interesting from our guests. And the first guest is Mike from ClickStack team. Welcome, Mike.
Hello, thank you, Alexei. Very cool. So really excited to talk a bit about our latest integration into ClickHouse Clouds. Hopefully you guys can see my screen there. Um, just a brief intro on ClickStack for those that are not familiar. It's the high performance open source observability stack built on top of ClickHouse. So the intent here is that we want to make it really easy for folks who are using ClickHouse for observability to turn it into a really fast to deploy stack. It's something you could deploy in seconds on top of ClickHouse, either an existing instance where you have OTel data or your logs data in ClickHouse already with a custom schema even, or on a new instance that might stand up. And the entire stack is built specifically for observability with observability specific schemas out of the box and workflows that work from anywhere from session replay and front end monitoring all the way back to your traditional logs, infrastructure metrics, and traces as well. Covers all those different use cases. And all these components are being maintained in-house here. ClickStack is being maintained in-house here at ClickHouse. So you know that it's going to be optimized specifically to unlock the potential of ClickHouse's performance. And the last part is that it's OpenTelemetry native, not exclusive, but we definitely support OpenTelemetry quite well. And it's also completely open source. And one thing we've introduced really recently for folks who are using ClickHouse Cloud is the ability to now launch ClickStack within your own ClickHouse Cloud service. So here I have my ClickHouse Cloud account, a demo account here, and you'll notice that there is a new icon here for ClickStack. So this is in private preview. If you guys are interested, please reach out or sign up online for the private preview. This is enabled on this account by simply just clicking on this icon with an existing ClickHouse instance. It will launch into the HyperDX UI, and it's automatically connected to your existing ClickHouse instances. And here I'm already seeing the logs that are coming through in ClickHouse in this UI. And for those who haven't seen the interface before or know what it can do, some of the kind of neat things that it's able to do, for example, is that it supports SQL querying, so it is really easy to go ask for give me all the services, service name that are load, for instance. So you can do queries like that. However, sometimes it's a little bit easier as well to express something in just kind of like a really terse syntax like Lucene syntax. So you can do the same thing in Lucene and even do full text search effectively, or you can just type in the words you're interested in, and it'll search your log messages based on top of that. But it could do a whole lot more than that, and it can analyze data in much more interesting ways. So another interesting kind of use case we help with is, say, for example, one of your coworkers told you, hey, we had a spike in errors in the last day. Can you help investigate this for us? And you see, well, you take a look at errors of the last day. There is indeed a lot of errors that were happening. But you'll notice that there's, hundreds of thousands of errors that happen, and it's really hard to tell exactly what is the set of errors that were actually important, since there's errors all the time. And one thing we also include, one of the features we also include, is something called event patterns. What we do is that we'll, on query time, analyze a set of those logs and look for common patterns or occurrences of those logs, and then collect the ones that look similar together. So you don't have to be exactly the same. You'll notice, for example, here there's wildcard characters being put in there, but they just have to be similar. It'll collect them together and then show you the trends of that cluster of logs over time. And here we have a few of these error messages. This one is probably the most interesting. We can click into it, see that there's a lot of individual instances of it, click into that again, and see a log. But of course, this log alone is not very helpful. The great thing about ClickHouse is that it supports all sorts of telemetry and all sorts of data. So not only can you have your logs in ClickHouse, if you're also sending your traces into ClickHouse and then have those correlated together, we can actually pull the entire trace as well. So not only do you see the specific message that went wrong, but you can see the entire request chain from the moment it was fired all the way down to the actual error. And in this case, we also have a bit more information about this error in the error span. In this case, we happen to enrich the error span with source map information, so you can actually see the original line of code that triggered this error. Not available all the time, but just available in this specific demo here as well. And that gives you a better idea of what happened. And then, of course, you can always look at what the other services are doing to get a bit more context on it. And again, another thing is that, of course, ClickHouse not only supports logs and traces, but also metrics. You can also see how the correlated infrastructure metrics, such as pod CPU, memory, disk, K8s, pod events, and node metrics as well, and how it correlates with those logs. So that's just really quick workflow as what you can do. And again, it's incredibly easy. You don't have to host anything additional. If you already have your telemetry in ClickHouse Cloud, if you're part of the private preview, which you could sign up for online, you simply just open this UI from here and you get this entire experience built in, no extra setup, no extra users needed to do. It integrates fully into your existing cloud account. So that's my demo. Please, if you're interested, reach out to sign up for the private preview.
That looks really good. And what is especially interesting about ClickStack is I don't usually like web UIs, for logs, they all look clunky, and this is probably the only one that does not look clunky.
Thank you, Alexei. Yeah, and there's also some nice hotkeys built in there as well. I'm sure as folks use it more, they'll find out all the nice things that are put into it.
Yeah, and we have something equally exciting, equally interesting, or even more about AI from our next guest speaker, Wagner. Please.
Hi, thanks for the opportunity to present my work here. Let me share my screen. Okay, can you confirm if it is sharing? Can you
Yeah, I
see
do.
my screen? Oh,
Uh-huh.
good. So, Lag is a Brazilian company. It was founded 15 years ago, and our core business is to provide the network infrastructure acceleration for video gaming. And how does it work? When someone plays a game to compete against others, it is necessary to connect to a server, and the server can be across the globe. The problem is with the traditional infrastructure. Uh, as you can see on the white network in the diagram, can be a lot of problems and delays. So the company provides private infrastructure using more than 1,000 servers spread over many different countries. And we provide a fast way for the gamers to connect to the game server. And well, we have around 2 million users around the world, spread over 190 countries. We support 2,000 games, and all of this generates a lot of data, telemetry data about the latency of our servers and our clients. So we do use the ClickHouse with a few thousand tables. We use it to store business data, but the biggest volume of data is latency data. Servers and clients generate around 200 million rows each day. And this is, let's say, what we use ClickHouse for. And we are doing many interesting experimentation with AI, using some interesting features that were made available recently on ClickHouse. So we do a lot of experimentation with LLMs, large language models, especially the open large language models where we can make private deployments. However, we also do use a lot private, or let's say closed large language models like Gemini. So we are doing experimentation on natural language processing, because those LLMs generate a lot of text, and we are starting to try the text retrieval features of ClickHouse, and also the vector search using multimodal vectors, not only for text, but for image and sound as well. The application that we are aiming is to understand how different games, how different stages at the games demands a lower latency, so we can, in the future, we will be able to optimize our infrastructure to provide a better experience to our users. And we are also enjoying the benefits of the MCP integration. Model Context Protocol is, well, it's kind of magic. It provides a seamless way to integrate many components of software to large language models, and it is a key component, a key building block to build very interesting tools. So now I would like to present a demo. Just a moment, let me. Okay, so on this demo, well, I hate online demos, so I recorded it to avoid problems. So on this demo, we have an integration with our ClickHouse infrastructure and Slack, so that we can use natural language to make queries. This is not new. It is something that is available on ClickHouse Cloud. So, but the point here is how easy is to make this implementation. I will show you one integration where the large language model used is Gemini from Google, and the interface is the Gemini CLI, Command Line Interface. This approach that I will show you is almost no code. So we have at the left the Slack channel. So I'm running the command line interface here just to show how the MCP servers that are integrated. There are hundreds, a few hundreds implementation of MCP servers. Well, I would say the figure goes already in the thousands. So for simplicity, I'm showing here an integration with just ClickHouse and Slack. So Gemini here, the command line interface, can integrate to the official MCP server provided by ClickHouse, and there is also this integration with Slack. So this is for interactive use. What I will show you is actually there is a very small shell script here where I run Gemini, I provide one prompt, and that's it. This prompt will do very interesting things. So a very small shell script here, an infinite loop where I call the Gemini and record logs. So it's running now. So here, now that it's running, I go to the Slack, and I mention my application integration, my robot. And well, I ask in natural language, I want to know the space used for each table on the analytics data science database. So I made the request. I can see on the right the Gemini and the MCP doing their work, and now the answer was generated, and I can see the answer. So here we have the results. This is an experimental small database, but we can see many empty tables, and one image embeddings that have more space used. Another video I have here will show how we can use the vector search capability of ClickHouse. So this is a very basic experimentation. We are doing much larger things, but for brevity, we are using a small data set with 9,000 images, and each image has a vector that is stored on ClickHouse, and I asked to find images similar to one image with the IG 1234. So it generated the response. So here's the answer, and it generated one PNG file where the Gemini is running. There is no integration of the Slack MCP to publish images. So I see the results manually here at my computer, and the first image is the reference. The image the reference image is not shown here, but we can see that all the cars are similar. The same model, I think, the same maker. Okay, so the data set, natural images, consists of very almost 10,000 images of different things like cars, people, cats, dogs, and so on. Okay, this is what I had to share with you. Thank you.
Yeah, that's look interesting, especially as it uses the built-in MCP server that is available in ClickHouse Cloud. And now let's back to the main presentation. And we have a quite busy schedule of meetups. Like in Singapore, it was today, so you already missed it. In Melbourne, it will be in just a few days. Then Tokyo, Madrid, Barcelona, San Francisco, Seattle, Zurich, Chicago, London. And we have a lot of many interesting content in our blog, like optimization of group by to thousands of CPU cores, optimization for high-core Intel CPUs, cost-efficient observability, migration from timescale DB, customer stories, how LLMs improve your work as SRE, many interesting stuff. And now we have probably -1 minute for questions.
And we have a few, Alexei, but let's stick to the ones which I think. I wonder if you can quantify this. Sorry if I don't pronounce this right. Kavaraj asked, any performance penalty for enabling the profiling in production?
Apparently, there is no performance implication. At least we did not detect any. We can say that we enabled the build of the profiler, so now it is built in. It
Okay.
is sitting there in the code, but to activate it, you have to enable these settings. So until it is not activated, there is absolutely zero performance impact. At least we did not see it on any of tens of thousands of customer instances. If you do enable query profiler, there will be a small overhead from pushing this data into the text log table, but for the profiling itself, it uses a certain sampling rate that makes it at least not easily noticeable.
Okay. That's great. Just two more then, I suppose. Let's do the ones which were fairly early on. Can we query ClickHouse and get results in arrow flight format?
Yes, ClickHouse can work as arrow flight server. So your applications can connect to ClickHouse and request data, which ClickHouse will provide using arrow flight.
Okay. And then the last two, which are both kind of vector search related, but one is actually embedded index related. One is any plans to support custom tokenization, and do we have any plans to support any other ANN indexes like scann or discan at ANN?
Yeah, this is a very interesting topic because HNSW requires to be in memory, and the size of HNSW graph is comparable to the size of original vectors. Slightly less with quantization, even less with binary quantization, but still these links in the graph, they take memory. And we consider disk-based algorithms, at least algorithms that are better optimized for disks. The problem is that HNSW is actually, when you do have memory, it is the best approach. It is better than any sort of dimension reduction, any sort of clustering. But when we have to store these indexes on disk, we have to consider other algorithms, and there is no a single best choice like HNSW. It will have we will have to do a lot of considerations for choosing.
And just to finish, I suppose custom analyzers for index. Is there any chance that we could just support generic expressions there, maybe for the embedded index?
Even now, you can do something like store the original message, but create an index on a lowercase message. So then you automatically get case normalization for the index. It is not as convenient as it could be. You'll have to write this expression again when using these functions, has token and other functions. But theoretically, it could be any function, any transformation.
Okay, great. I think that's it. Probably what we've got time for. We're 10 minutes over. Thanks, everyone, and thank you to Alexei, and thank you for our guest speakers. Tyler, anything to say?
Now, I was just going to say the exact same thing. Thank you so much. I mean, fundamentally, Wagner, what you shared is super exciting. And it's really cool. Having spent a day sitting here at a booth in PyData Amsterdam, talking about AI, to see someone doing what other people are thinking about is incredibly motivating. So for myself in Amsterdam, from Alexei in Singapore, from Dale in Scotland, from somewhere in Brazil, from Mike in California, it is a global community, and it's a global community of people who are deeply passionate about fast databases. Feel free to join us, clickhouse.com/Slack. And I want to hear online, what's your favorite feature? which is the one you're going to use first. See you next month.
See you.